Hello class. In this video, this is part 2 of finding the zeros of polynomials. So in this video we're going to be talking about finding the zeros of polynomials when the polynomials are actually two linear equations multiplied together. So let's remind ourselves, what is a zero of a polynomial from last video? Zero of a polynomial is an x value when y is equal to 0. When y equals to 0, x has to equal something. Whatever it equals, that's a zero of the polynomial. All right, so a key understanding of this problem, of this kind of problem, is to know that anything times 0 is 0. Or, put it another way, 0 is the answer for any multiplication problem that involves a 0. So when you multiply 2 times 0, since 0 is in that multiplication problem, the answer is going to be 0. It doesn't matter that there's a 2 there. Or, look at this one. When you have the problem 0 times negative 17, for example. Since there's a 0 in that multiplication problem, the answer is going to be 0. Doesn't matter that it's a negative 17, doesn't matter the other number is a 2, it doesn't matter what that other number is. If a 0 is part of the multiplication problem, 0 is your answer. All right, so let's get to it. We're going to try to find the zeros of this function, which is two linear equations multiplied together. So the first thing I'm going to do is I'm going to take the first linear equation, the thing in the first parentheses, and I'm going to make that equal to 0. I'm just going to make it equal to 0 and see what x needs to be for that to be true. Well, this is the same kind of problem that I did last video. I'm just going to subtract a 1 from both sides, and I've got that negative 1 is equal to x, or put it another way, x is equal to negative 1. Okay? So if this first linear equation, if that's going to be equal to 0, then x has to be negative 1. I'm going to do the same thing with my other linear equation, x minus 3. I'm going to set that equal to 0 and see what x needs to be to make that true. So if I add 3 to both sides, I've got 3 is equal to x, or in other words, put it another way, flip it around, x is 3. So if x is negative 1, that means that my first linear equation, the one that comes in the first parentheses, is 0. And if x is equal to 3, that means x minus 3, the thing that's in my second parentheses, that means that's equal to 0. Okay, so one of these x values makes the first parentheses 0, and the other x value makes the second one 0. Why is that important? Well, the reason that's important is because, just like we said with the key understanding, when you multiply anything by a 0, it doesn't matter what the thing is. If you multiply it by a 0, the answer is 0. So, let's say x is equal to negative 1. If x is equal to negative 1, then this whole equation becomes y is equal to negative 1 plus 1 times negative 1 minus 3. Okay? But we know that negative 1 plus 1, that's just 0. Negative 1 minus 3 is negative 4, but that doesn't even matter because we're already got 0 times something. We know the answer to that. The answer to that is going to be 0. So when x equals negative 1, y is equal to 0. But look at this. Our definition of a 0 of a polynomial says it's an x value when y equals 0. So if x being negative 1 makes y equal to 0, then negative 1 is going to be a 0 of the polynomial. Okay? Negative 1 is a 0. Let's look at this other x value that we came up with. If x is equal to 3, what happens to our equation? Well, It's going to be 3 plus 1. I'm just replacing my x's with 3 because x is equal to 3 here. Then 3 minus 3. Now, 3 plus 1 is positive 4. And 3 minus 3, isn't that just 0? Well, look at that. We've got a multiplication problem with the number 0 in it again. And we know that any time you have something times a 0, the answer is going to be 0. So when x is equal to 3, that also makes y equal to 0. So negative 1 is not our only 0 here. It's not the only x value that makes y equal to 0. Negative 3 is a 0 too. So I've got to actually say negative 1 and positive 3 are zeros. I've got 2 zeros here. 2 zeros here. One for each of these linear equations. All right. Let's do a few more examples just a little bit faster. So remember, what I do is I see what x would make the first function 0, the first linear equation, and what x would make the second linear equation 0. And because anything times a 0 is 0, both of those x values are going to be zeros of this whole function. So if I set 2x plus 1 equal to 0, what does x equal in that case? Well, 2x is equal to negative 1 if I minus 1 from both sides, and x is equal to negative 1/2. Okay, what about this? What about this equation? If I set it equal to 0, x minus 3 equal to 0. I can add 3 to both sides, and I have x is equal to 3. So what I found is that negative 1/2 and 3 are both zeros. Negative 1/2 and 3 are both zeros. And you can try it out. You can put negative 1/2 in here for x in both spots and work this all out and see if y equals 0. It will. Also with the 3, you could put 3 in here for x in both spots and work that out, and it's going to make y equal to 0. All right, let's try one more example here, and then I'll have you work on the last two on your own. So, y is equal to x times x plus 3. Okay. Now, this doesn't look quite like my other examples. My other examples, you can see they all have 2 sets of parentheses multiplied together. But this one really is like the other examples. Here's why. Because all of these are 2 linear equations multiplied together, and that's what I have here. I have x just by itself. X by itself is a linear equation, even though it just has one term, because it's to the power 1. And then we also have x plus 2. So x times x plus 2. X plus 2 is a linear equation. X by itself, that's a linear equation too. 2 linear equations multiplied together. So I'm going to set both of them equal to 0 and see what x has to be to make that true. Well, the first one's the easiest. Look, since the whole linear equation is just x, if I set that equal to 0, it tells me pretty straightforwardly that x has to equal 0. Let me set the second linear equation equal to 0. The second linear equation equals 0. 0 is x plus 2. What does x have to equal? Well, I'll subtract 2 from both sides, and x is equal to negative 2. So what we found here is that 0 and negative 2 are zeros. Both of these numbers are zeros of this particular equation. All right, so the pattern is if I've got 2 linear equations multiplied together, I'm going to figure out the zeros of both of them, and those are both going to be zeros of the whole equation. Let's see if you can do that for this example. So, if I take my first linear equation and set it equal to 0, 0 equals 2x minus 1. Add 1 to both sides. 1 is equal to 2x. Divide by 2. 1/2 is equal to x, or put it another way, x is equal to 1/2. If I set my second linear equation equal to 0, 3x plus 2 equals 0, I'm going to subtract 2 from both sides. Negative 2 equals 3x, and I'm going to divide both sides by 3. Negative 2 over 3 is equal to x. Okay, so another way, x is equal to negative 2/3. So what are my zeros? My zeros are x equals 1/2. That'll make y equals 0. And x equals negative 2/3. 1/2 and negative 2/3 are zeros. All right, give this last one a try. Okay, so if I set my first equation equal to 0, it's pretty clear to me that x should equal negative 7. And if I set my second equation equal to 0, it's pretty clear to me, if I work that out, that x should equal 5. So negative 7 and 5, x could be either of those, and that would make the y equal to 0, which means that negative 7 and positive 5 are zeros.